Hi there, Mr. Biggers here, and today we're learning Module 2, Lesson 4, Day 2. Still learning the solving systems of equations graphically. So remember, a system of equations is two equations that's graphed. The solution to a system of equations is the point in which the two lines that you graphed intersected. That solution has both an x and a y coordinate. Also, if you have the notes from yesterday, the day 1 notes, we talked about systems being consistent, inconsistent, independent, and dependent. So make sure you brush up on that so you're familiar with those definitions. Moving on, we have this example 4 here. Suppose an electric car costs $29,000 to purchase. So it has an initial cost of $29,000, and then it has an additional cost of 0.36 or 3.6 cents per mile to drive. And a gasoline-powered car costs $19,000 to purchase, and it costs 8 cents per mile to drive. Estimate after how many miles of driving the total cost of each car will be the same. So part A says write equations for the total cost of owning each type of car. So equations, especially if we're graphing, is going to have both an x and a y. Okay, not sure why my pencil is acting funny, but they will have both an x and a y. So usually your x-axis is going to be something countable, something tangible like time or distance traveled, those sorts of things. So in this specific example that we're looking at, we do have something that's countable, and that is the specific miles that we have. So in this case, x is going to be our miles, okay? And then our y variable is going to be our cost in dollars, okay? So writing an equation, we have to write two of them. So we have a system of equations. So we have an equation for an electric car. We know an electric car, the total cost, y, is equal to the 0.036 per mile it costs, added to the additional cost or the initial cost that we had, which was the $29,000. So that is an equation for the electric car. And then in the same sense, the equation for the gas car is going to be the cost is equal to, it's costing us 8 cents per mile to drive this car, and the initial cost of the car was $19,000. These are your system of equations, and that's how you can write it, okay? They went ahead and graphed those systems for us and found that point of intersection. So part B, we want to examine the graph to estimate the number of miles you would have to drive before the cost of owning each type of car would be the same. Okay, so at first, the electric car costs a little bit more. This is in thousands of dollars, so right off the bat, the electric car is more and the gas car is less. But as these graphs continue in the miles that you drive here, like if you look specifically here, okay, now we're at this many thousands of miles, and we're getting closer to the cost of the electric car. Now, as that gasoline car makes it all the way over here, it looks like in between 210 and 270,000 miles, so about 240,000 miles, your cost of the gasoline car is actually now going to surpass the cost of the electric car. So I have just identified one of the points there, or very close to it. So this would probably be an estimate, a y or an x coordinate estimate of, I would say, in between 210 and 240. So we're gonna go with 225. Okay, so 225,000, and then if you look here at the same respect, like where you're going to be at on your cost, if you go straight over from that point, you are going to be in between 35 and 40,000. So I would say 37.5 thousand. Sorry, we glitched out there. Okay, so they intersect approximately at that point. So I think I said the x was 225,000 and the y was approximately 37.5. This means that after driving about 225,000 miles, the cost of owning each car will be the same, and that cost will be $37,500. That is how you can use a graph to help you with the system of equations here. Now, sorry, since it glitched, I have to put that on there. Okay, now for example 5, I want to show you how to use technology to help with these. So the first thing you need to do when you're graphing is solve for y. You want it to be in slope-intercept form. We've talked about this form over and over and over again. So the first one, I'm going to go ahead and solve it. So 3.5y is equal to, I'm going to add that 5.6x over to the other side. And then I'm going to divide everything out here by 3.5. Don't let the decimals scare you or make you run away or, whatever, because it's really not bad. Just use a calculator and everything's going to be just fine. So I'm going to go ahead and type this in. 5.6 divided by 3.5. That is 1.6x. Plus, we're going to do 18.2 divided by 3.5, and that's 5.2. So that is the first equation, 5.2. Okay, and then the next one, we're going to do the same thing. So I have that negative y. I'm going to go ahead and add my x over to the other side, so it's over there. So it's going to be 0.7x. And then minus that 2.4 that's still over there. I'm looking at the second equation now. And then to get rid of the negative, you can just divide everything by -1. Makes it easy peasy. Y is equal to negative 0.7x plus 2.4. So you have two equations here. Now, this is not realistic for us to just graph on paper like you would on your bell ringer. This is something that we need technology to graph. So we are going to move to Desmos to help us graph. Now, Desmos has an app, so at home you can use it on your phone, or if you have an iPad, you can do it. You can hop right over here and see that I have the Desmos app here. But for today, I'm going to show you it and how to get to it on class info on the computer. So I'm going to go ahead and hop off of the notes and hop onto the computer. So here we are on our Canvas page. So to get to Desmos and to graph these things, you're going to want to hit to links and info. It's going to show you all kinds of things, but the most important thing is this, the Desmos graphing calculator. You can Google this or go to class info and there's a button here. You're going to want to click into the calculator, and now what I'm going to do is type on my keyboard exactly what we just came up with on the notes. So I have y equals 1.6x plus 5.2, and then I have the other one, y is equal to negative 0.7x plus 24, okay? So the solution to these two graphs is where they intersect. You might be wondering, I only see one line. Why is that? Well, the other one, if you look, is all the way up here. So on a tablet, you can just scroll around and pinch to zoom. On a computer, you can also pinch to zoom, or use the plus and minus to zoom in and out. Now on Desmos, they make it really easy to see the intersection. All you have to do is take your cursor and click over where the two graphs meet. And then you have the x-coordinate of where they meet and the y-coordinate of where they meet. So the intersection of this system is at 8.17391, comma, 18.27826. That is the intersection of those two graphs, okay? Now, in this particular problem, we're just dealing with some random variables. It's not like a contextual problem or means anything, so that's just the answer, okay? If it specified us to round a certain decimal, we would need to do that, but on the notes, I'm just going to write that as the answer. Now, in the same sense, we're going to do this example. And you're going to see problems like this on your assignment. You're going to want to use the Alex graphing calculator to solve the system of equations and round to the nearest hundredth. Remember, that is 2 decimals. Okay, so an example would be 8.139. Rounded would become 8.14. Remember rounding, how you would do that. Okay, that's just an example for you. So I'm going to go ahead and get rid of that so we aren't confused with that. Now, to solve this, it says Alex graphing calculator. You don't have to use that. Use Desmos. Okay, we're not going to use Alex graphing calculator. What we're going to do is graph. Remember, you're going to type in equation 1 on Desmos and equation 2, exactly how they appear. You are going to find their intersection. So find their intersection. Okay, so you're always going to have an x coordinate and a y coordinate when you're graphing these. So I'm going to go ahead and hop over to Desmos real quick. Let me see if I can actually do it side by side. Yes, this is perfect. Okay, so I'm going to go ahead and type it in. I've got y. The first one is y equals 3x minus 5, and I don't want to forget my negative. So there's the first graph, and then the second one is y equals negative 10x minus 9. Okay, so remember, you can pinch to zoom on the computer and on a tablet or phone, and you can click and just see right where the intersection is. So once you click it, it actually gives you this button too. It'll make it a point off to the side so you can see exactly that point of intersection. So it says round to the nearest hundredth. This is important because Alex will not give you the right answer unless the rounding is correct. So I'm looking at my negative 0.57143, the nearest hundredth of that. And let me go ahead and write the other coordinate too. So the other one was the 3.28571. All right. So the nearest hundredth is 2 decimals. So I thought I just changed my color, but I guess not. So 2 decimals. So the x coordinate of the solution is negative 0.57. And the y coordinate of the solution is negative 3.29. That 5 makes the 8 round up to a 9. This would be your solution. Use this to help you on the assignment. Also, the first couple questions on the assignment are talking about yesterday's notes and talking about just those things. So make sure you look over those notes so you know what's going on.